Now I do record everything and I post all these to YouTube. So if you miss a day, they are accessible. And I can talk to you more later about everything and get you caught up. All right? What we're doing today is long division. And we're dividing polynomial functions using long division. Now before we get into actually dividing with long division of polynomials, we're going to start out with dividing actual two numbers. So whenever we divide two numbers using long division, the first thing we're doing is trying to simplify these numbers out. So we need to see what times 13 gives us 29. So we could try, because we know it's not going to be 1. So we can try 2. We can say 2 times 13 is 26. And that is definitely close to 29. So we'd put a 2 over the 9 and put 26 underneath. And then we would subtract. 29 minus 26 is going to be 3. Then the next thing we'll do is drop the 6 and do it again. So we need to see what number times 13 would get us close to 36. Because we could try 3, which is 39. So that means we're just sticking with 2 again. We already have 2 times 13 is 26. And then we would subtract. 36 minus 26 is 10. Then we'll bring the next number down. Now we see how many times, or what times 13 will get us close to 108. So it's either, we can look at 8. 8 times 3 is 4, carry the 2. 8 times 1 is 8, plus 2 is, we get 104. And again, we would subtract. Give us 4. And then bring down the 2. Now we would have 3, which would be 39, gives us 3. So essentially this process is going to be very similar to what we're doing for long division with some polynomials. I picked this up to get this to you. So the note sheets there are going to follow essentially what we do up here. Do you need a pencil? Now, 13 won't go into 3. We don't have any other numbers we can bring down. So we can write it as a remainder.
So the 42 and the 39
Yes. Mm-hmm. Now, you don't have to write this down. I put this up here so that y'all can kind of see it. Whenever we divide a polynomial f of x by a non-zero divisor d of x, you get the quotient. So what are 2,283, and then a remainder, which was our 4 divided by what we were dividing, so 13. So we're going to do this first one here. We're actually going to divide polynomials. So on the back of the first page, we'll look at this here. So when we divide two polynomials, the first thing we're going to do is set it up. So we're going to start with this here. And we're going to put this here inside. So we'll have x to the third minus x squared plus 2x plus 8. And what goes outside is what we're dividing by, our divisor, our x plus 1. Now, if we have any terms missing, so here our first term, our first variable is x to the third. So we'll need x to the third, x squared, x, and then our constant term. If any one of these is missing, we're going to add it back in as 0 times whatever that variable is. So if we were missing an x squared, we can rewrite it in as plus 0x squared. So it's more of holding a place so when we go through the process, it's not going to kind of line up weird. Questions on this so far? Now, with dividing polynomials by long division, we want the first term, kind of as we work this out, to cancel out. And to get that, we need to see what times x will give us x to the third. X squared, yes? So, we're going to multiply, to start the division, we're going to multiply this by x squared and put it underneath, kind of like what we just did with the previous problem. So we'll start out with doing x squared times x plus 1. And we can do this work off to the side so we can see it. X squared times x is x to the third, like we wanted. X squared times 1 is going to be plus x squared. Then we will put it underneath, so we will have x to the third plus x squared. Any questions on any of this here so far? Just like with the previous long division problem, the next thing we're going to do is subtract. X to the third minus x to the third is 0. It cancels out. Those are gone. Now we look at the next one. Negative x squared minus x squared is negative 2x squared. Negative 1 minus 1 is negative 2. Then, so far it's kind of similar. It's different than long division, but the process is kind of similar in what we're doing. And again, in long division, our next step was to bring the next term down. So here we're bringing down the plus 2x. Any questions on any of this here so far? Not too bad so far. Well, at this point here, we repeat the process. We're really essentially restarting what we just did, but instead of seeing what times x will give us x to the third, we're trying to see what times x will give us negative 2x squared. It should be negative 2x, because negative 2x times x should give us negative 2x squared, because we're trying to simplify this one spot at a time. And negative 2x times, well, negative 2x times x would be negative 2x squared. Negative 2x times 1 is negative 2x. At this point here, we'll put it underneath. And then again, we are going to subtract. Yep, because we always want the first one to cancel. Negative 2 minus negative 2, well, the negative would make a plus. Negative 2 plus 2 is 0, just like we wanted. The next one, 2x minus negative 2x. Well, the negative would make a plus. 2x plus 2x is 4x. And again, we bring down the last term, which gives us plus 8. Questions on this so far? We repeat it again. So what times x will give us 4x? 4 plus 4, positive 4. So now we can multiply 4 by x plus 1. Well, 4 times x is, and 4 times 1 is plus 4. And then we'll subtract. 4x minus 4x is 0. They cancel out. And 8 minus 4 is 4. Do we have any more terms to bring down? No. How many terms do we have left? 1. How many do we have that we're dividing by? 2. So we're done. If we think of it as the degree, well, the degree of the polynomial that we have left is 0. Because there is no variable, so that means x to the 0. That's the degree. Now, the degree of what we started with, or what we're dividing by, is 1, yes? Whenever the degree of what we're dividing by, our divisor, is bigger than what we have left down here, then we're done. Because we can't divide any further. Essentially, what we're saying is that this here is smaller than what we're dividing by. Kind of with the first one. When the number got smaller than 13, we're done. We couldn't do any more. Any questions on this so far? Now, we do need to pull the remainder in. So we're going to add it to it. And whatever is left on bottom, whatever we have left down here, we put it on top of the fraction. And what have we been dividing this by this whole time? And it goes on bottom. That's it. Questions on this here? Not too bad so far? I haven't completely lost you yet? No? Let's look at the next one here. So we're going to divide these. So we can start off by setting up our division here. So inside, we put the one that goes first, so we have 2x to the 4th. Plus 3x cubed. Well, the next term we have is 5x. We don't have an x squared term. So what we'll do for this here is add in 0x squared plus our 5x minus 1. So if we have a term missing, we'll add it in with 0x. And what we're dividing by goes in front, so we would have our x squared plus 3x plus 2. So we good with how we set this up, yes? I mean, for the most part, it's just mainly like setting up long division. Now, again, our first main step is to see what times x squared is going to give us 2x to the 4th. What do we need to multiply x squared by to get 2x to the 4th? 2x squared. And I will always put that above. It's kind of like terms. So since we're multiplying it by 2x squared, I will put it over the top of the x squared term. And what's interesting, this here kind of does help tell us which is going to be the first variable we're multiplying by, is if we look at this here, how many terms do I have? 3, yes? Well, we always got to start on the leftmost one. So I have 1, 2, 3. Our third one is what? Over the top of x squared. They'll always line up this way. Because if we look back at the first one, well, how many terms did we have here? 2, 1, 2. We started off with an x squared. It'll always line up that way. So here we go over 3. It means we need the x squared. And it is 2x squared. So now we multiply. So we're going to say 2x squared times x squared plus 3x plus 2. And we'll distribute it out. 2x squared times x squared is 2x to the 4th. 2x squared times 3x is going to be plus 6x cubed. And 2x squared times 2 is going to be plus 4x squared. And again, we're going to subtract. 2x to the fourth minus 2x to the fourth. It is 0. Our next one, we have 3x cubed minus 6x cubed. Well, 3 minus 6 is negative 3x cubed. The next one we have is 0x squared minus 4x squared. 0 minus 4, negative 4x squared. We bring down the plus 5x. And again, we're going to repeat this process. So we're now seeing what times x squared will give us negative 3x cubed. Well, we have 1 in front of x squared, and we need it to be negative 3. So we will multiply it by negative 3, yes? And we'll also need a what? X. If you notice that the terms are lining back up, which means the next number we multiply will just be a constant number. So we'll do this again. So we're going to multiply negative 3x by x squared plus 3x plus 2. Negative 3x times x squared is negative 3x cubed. Negative 3x times 3x is going to be negative 9x squared. And lastly, negative 3x times 2 is negative 6x. And we're going to subtract again. So the first one we have is negative 3x cubed minus negative 3x cubed. Again, that is 0. That's what we want it to be. We want it to be 0. Now when we look at the next one, negative 4x squared minus negative 9. Well, the negative and negative would make a plus. So we're looking at negative 4x squared plus 9x squared, which is 5x squared. The next one we have 5x minus negative 6x. The negative and negative would make a positive, giving us 5x plus 6x, which would be plus 11x. Bring down the negative 1. So we need to do this at least one more time because we did bring down the last term. So we're trying to see what times x squared is 5x squared. It's going to be 5. So we're going to multiply 5 by our x squared plus 3x plus 2. Well, 5 times x squared is just 5x squared. 5 times 3x is plus 15x. And 5 times 2 would be plus 10. So we have 5x squared plus 15x plus 10. And again, at this point, we'll subtract again. 5x squared minus 5x squared is indeed 0. 11x minus 15x is x. And lastly, negative 1 minus 10 is negative 11. And we're finished. One way we know we're done is because the degree that we have now is 1. The degree of what we've been dividing by is 2. So we have finished with this here. So the final answer we have is 2x squared minus 3x plus 5 plus what we had left over, negative 4x minus 11 over x squared plus 3x plus That's it. How do we feel about this here? Yeah. I mean, on the whole, it's not terrible.
It's not hard. It's just.
Yeah. It's long. Long and tedious. Yes. Would we at least agree with that? Long and tedious. Dude, I know you'd rather be doing something else besides this. I know I'm the only one that would enjoy doing this, so there's a reason I'm doing this. But any questions on this here? No? We're going to look at two more of these here. So we'll put what's inside first, so we'll have 4x to the fourth. Well, this one here, we don't have an x cubed term, so we'll add it in as plus 0x cubed. Fortunately, we also don't have an x squared term, so we'll have to add it in as 0x squared. But we do have a 5x. We do have x to the first minus 4. I'll put the other one out front, x squared minus 3x minus 2. Now the first main step is seeing what times x squared will give us 4x to the fourth. 4x squared. 4x squared is what we need. So we're going to multiply 4x squared by our x squared minus 3x minus 2. So we'll distribute these out so that we get what we need to be able to do our subtraction. 4x squared times x squared is going to be 4x to the fourth. 4x squared times negative 3x is going to be negative 12x cubed. And 4x squared times negative 2 is going to be negative 8x squared. And again, we'll put this underneath what we have here. So all 4x to the fourth. That's 12x cubed x squared. And then we will subtract the 2. Now 4x to the fourth minus 4x to the fourth is indeed 0, so they will cancel out. Our next one that we have is 0x cubed minus negative 12x cubed. This is just going to be 12x cubed. So 0 minus negative 8, or 0 plus 8x squared. It's going to be 8x squared. Then again, we bring down the plus 5x. No, right there. And then we repeat the pattern again. Well, it needed to be actually a square. Now we need to see what times x squared gives us 12x cubed plus 12x. So now we're going to multiply 12x by our x squared minus 3x minus 2. So now we can distribute the 12x. 12x times x squared is going to be 12x cubed. Then we'll do 12x times negative 3x. Well, 12 times negative 3 is negative 36x. And it'd be squared, because x times x would give us x squared. And 12x times negative 2 is going to be negative 24x. And we'll put this right underneath. So we'd have 12x cubed minus 36x squared minus 24x. and we're going to subtract again. So 12x cubed minus 12x cubed. These here are going to cancel out. They're going to become 0. Then we'll move on to the next one. 8 minus negative 36, 8x squared minus negative 36x squared. Well, the negative make a positive, and indeed, 8x squared plus 36x squared is 44x squared. Our next one, 5x minus negative 24. Negative make a plus. And we have 29x. And lastly, we bring down the negative 4. Okay, so let me scroll. Now we need to see what times x squared is going to give us 44x squared, which is just going to be plus 44. So now we're going to multiply x squared minus 3x minus 2 by 44. And we'll distribute this here, so we'll do 44 times x squared. And 44 times x squared is going to be 44x squared. 44 times negative 3x, well, 44 times negative 3, I believe is negative 132, and we have x. And lastly, we'll do 44 times negative 2, which is going to be negative 88. So we're going to have 44 x squared minus 132x minus 88. And again, at this point here, we're going to subtract. So 44x squared minus 44x squared is 0 again. So these will cancel. Our next one that we have is 29x minus 132, negative 132x. Negative and negative make a positive, so 29 plus 132, 161x. And again, we have another negative and negative, so negative 4 plus 88 is plus 84. Any questions on this here? So what we have is, sure, 4x squared plus 12x plus 44 plus, we take what we have as the remainder, 161x plus 84, and we put it over our x squared minus 3x minus. Any questions on any of this here? Any questions over anything we've done so far? Not overwhelmed too much? Yep. We're doing that tomorrow. We're going to do one more and then we're done for today. So we're doing one more example problem together. And because we're going to look at this one here. I'm jumping all the way to the back. Last problem. And I'm doing this one in particular for two reasons. One, we have some spaces to fill in, and two, this one here is going to work out to not having a remainder. So this one won't have a remainder for us, which is kind of nice. Now, if we fill in what goes inside this here, we would start off with x to the fourth. We don't have an x cubed term, so we can add it in as 0x cubed. Then we have our plus 4x squared plus 0x minus 45. On the outside, we have our x squared. We don't have an x term, so we fill it in as 0x, and then we have our 9. Questions on how we set this up? Now for this one here, we could have gone without adding the 0x's in just because of how the setup is. But if we had something other than x squared plus 9, we would need those spots filled in. So it's better to fill them in and not need them than to have not and actually needed them. Now again, the first thing we're looking at is what times x squared gives us x to the fourth. X squared. And I'll put it over the x squared. And again, we can multiply this out. So we'll do x squared times x squared plus 0x plus 9. Multiply through. X squared times x squared is x to the fourth. X squared times 0x is, well, plus 0x cubed. I mean, it's still 0. And x squared times 9 is plus 9x squared. So, and we could fill that in here. So we'd have x to the fourth plus 0x cubed plus 9x squared. And again, we're going to subtract. Well, x to the fourth minus x to the fourth is 0, yes? 0x cubed minus 0x cubed. 0. Now, we could have left it, we could leave it in as 0x cubed and go from there. Or we can cancel it out either way. It'll still work out to be the same. There's just something special we have to do if we get rid of it. Now, the next one we have is 4x squared minus 9x squared. Negative 5x squared, yes? We bring our next term down, which is plus 0x, yes? How many terms do I have down here now? 2. How many am I dividing by? 3, yes? Do I have enough? No. So what we can do is bring down the minus 45. If you remember back to doing long division, it's been a while since you've actually had to do long division because we can use calculators. If the number was too small, we had to bring another number down. That's all we're doing. And lastly, what times x is negative 5x squared? Negative 5. So the last thing we can do is multiply through by negative 5. Negative 5 times x squared is indeed negative 5x squared. Negative 5x times 0x is 0x. So negative 5 times 0x is just going to be 0x. And negative 5 times 9 is negative 45. And at this point here, we will subtract. Negative 5x squared minus 5x squared is 0. 0x minus 0x is negative 45 minus negative 45. It cancels out at 0. All this becomes 0, yes? So, minus 5. That's it. Because if it works out the remainder is 0, what's above our division line is the answer. We don't have to add anything to it. Any questions on any of this here? And that's it. So the homework is on page 187, problems 5 through 10.